Hello everyone. In this video, I will try to my best to help you prepare for your FE exam for civil engineering in for this structural analysis section. Okay, if you look at the FE manual in your page 268, that's where the structural engineering section begin. But the first part is structural analysis. For the first part is the influence lines for beam and trusses. So if you look at the description there, it is given that what you need to consider, or what are the possible questions that or concept that you should be familiar with, is that if there's a movable set of loads that passes through the beam, what will be the maximum value of that effect? For a beam, we have reaction, shear force, and bending moment. And for a truss, we are interested to find only the bar force or the axial forces, which means that the maximum forces that caused by this movable set of loads. Okay, so my intention here is to help you prepare as you are preparing for your FE exam. What are the possible questions, or what are the possible variation that you may expect from this section? So that is my genuine hope, and I hope that it may give you confidence while preparing for this class. Okay. Okay, so what about trust? Okay, so the trust, generally sometimes you'll see in your NCEES practice problem, you'll see that they'll give you a trust, and they'll ask you which one belongs to uh, which influence line in a member. So sometimes you don't need to do calculation right away. You can use the concept of a beam. You know that uh, if this is a beam, and this is your roller support, and this is simply supported, and if you're applying a load over here, we know that this beam will deflect. Okay, and if it deflect, we know that this will be, the top part will be compression, and the bottom part will be tension, which is positive, and compression will be negative. Okay, so now you can see that this whole this whole truss you can consider as a beam, and you're going to apply a load over here. And if you apply a load anywhere on the bottom chord, remember that this is a bottom chord, this is your top chord. So if you're applying a load anywhere on the bottom chord, it will deflect. So you know that this bottom chord will always be in tension, and the top chord will always be in compression. So uh, from here you can tell that this is because this is the original undeformed section, and anything below will be negative and anything above will be positive. So you from here you can tell that which one is positive and which one is negative. So this whole thing will be positive, so which means that this is your influence line for BC. And because this part is going to be in compression is negative, so this part will be your influence line for EF. So sometimes they are not asking you to derive or to find the value for the influence line, or the maximum actual force um, in a truss. They'll just ask a simple conceptual question, that which influence line, um, which of the following belongs to the influence line for EF. So you know that EF will be in compression, so you'll see that the whole section will be in compression, which means that as the load is moving from A to D, this part will be always in compression, and the similarly, as the load is moving from A to D, this part will always be in tension. And what about the diagonal part? The diagonal part will be depends on how the load is moving. So you'll see that as the load is moving close to B, this will be in tension, and then as it leave the joint B, it will be in compression. Okay, so which means that at the leave it's being compressed, and as it move, it's being uh, uh, applying a tension field. So this will be your influence line for PF. Okay, so that is all about the influence line for truss. And in case you wanted to know, like, how do we how do we how do we calculate it, the influence for truss, we'll again use the concept of influence line. First of all, you want to know what is the influence line of AY uh, reaction, and we have already calculated reaction. So we'll apply a unit load, and it will be a triangle because we cannot move the joint D, and joint A is only allowed to it's the restraint is moving so that it can move by one distance. And because this is A, B, C, D, because A, B, B, C, C, D are equal length, so we know that this will be 2/3 and this will be 1/3. This will be 0, which basically means that as the load is over D, your AY will be 0. Okay, so for the same thing also, please remember in the truss, when you calculate the influence line for a truss, when the load is exactly at the support, your influence line will be 0. Please make sure that you know that when the load is at support, we expect that the whole load will be taken by the support, and so there will be no load expected in the any member of the truss, which is not true in real life. But for this analysis, because of the assumption that we make for truss, so we expect that the truss will be, if the load is applied at the support, the support will resist the whole load applied. Okay, so first you have to draw the influence line for AY, and then once you do that, you just need to cut the section. If you cut the section and you draw that AY, and then you have here B, and always draw the positive sign convention, EF, and this will be FBF, and then this will be FBC, and these forces will meet at joint F, which is important. I'll tell you later why. And I'm going to draw another one. Okay, so I'm going to draw another one because the reason I'm drawing another one is this is the load at B, and then this is the load at B, unit load, and this one is unit load at C. And because it is unit load at C, so you won't see any unit load at any it only passed the joint B. Okay, so in this case your AY will be 2/3. When the unit load is at B, your AY is 2/3, and when the unit load is at C, your AY will be equal to 1/3. Okay, so once you have that, once you cut the section, you don't have to calculate, like I said, you don't have to calculate influence line for the reaction because we all know it's going to be 0. And for here, to find FEF, use summation of moment about B equal to 0. Why? Because you'll see that if I take a summation of moment about B, these will not produce any moment. So the only force that will produce moment is FEF and AY. And I know if I wanted to find FEF, and I know the value of AY. So if you take a moment about B, you'll see that all this FBF, FBC will be 0 because they won't produce any moment. So that's a trick for using the to find the influence line or the force for EF. Okay, so now another one is to find FBC, use summation of moment about, this is your E, use summation about E equal to 0. Sorry, not E, it will be summation about F equal to 0. Okay, so why? Because you see that all this force will FBF and FEF will produce 0 moment. So the only, if you take a moment about F, you'll see that FBC will produce a counterclockwise moment, and FAY or AY reaction will produce um, clockwise moment. So if you take a moment about F, so you can find FBC because you already know AY. Okay, so that's a trick. And then if you want to find FBF, then you will not use moment. If you look clear, if you look here, you'll see that FEF is along x direction. If this is your coordinate axis, your x, your y, you'll see that your FEF is along x direction, FBC is along x direction. So all you have to do is summation of fx equal to 0. You'll find FEFY, and from there find FEF. FBF, sorry, not FEF. FBF. So that's the only trick you have to know when you solve for a truss. And you can use the same logic even for calculating all the member trusses also when you want to calculate method of section. Okay, so I hope that will give you a general idea of how to prepare your FE section of your structure analysis for inference line for beam and truss. Thank you.